So in this last video for us for the quarter, I kind of want to do a quick demo that kind of wraps up everything we just talked about today in terms of bash scripting. And then I want to quickly kind of tie up the whole quarter, kind of do a quick recap of everything we've seen, and then talk a little bit about what might be next for you. So in the last videos, we introduced like the basics of bash scripting and some constructs or programming constructs like loops and the weird if statements. And one of the powers that you have now that you know how to write scripts in bash is you can now automate a lot of maybe tedious tasks in your life as long as you can write a bash script to do it. So this exercise, or this demo in particular, is a bit of meta exercise about 391 in particular. So suppose, for example, we had like a final project or a final exam in this course, and you wanted to go back and make sure that you could go see all of the lecture content, like all of the code files from all the different lectures without having to go to our website and kind of click through every single file to download it. So we're going to try to see if we can automate that process. So I'm going to go ahead and I'm going to write a script called download lecture.sh. And we're going to do this in phases. So I'm going to start with the shebang like normal. So bin bash. And then if you go look for, I don't know, say this lecture, I always show you a command for each lecture for how to download it. So we can go here and we can paste this. Oops, I put I in front. And so this is the command that would go through and like gather these files. So I'm going to go ahead and actually I'm going to make a directory for this lectures, and I'm going to move download lecture there. The lectures. And we're going to edit this here. So first we're going to chmod plus x this thing so that we can actually run it. And then we can go ahead and try to run this thing. And you can see here that it went through and it ran both of those commands, right? It does exactly what we told it to do. I'm going to do this split screen again so that we can see both of these. Lectures. We'll open it. And you can see here, if ILS, I have these directories because I just went through and ran all that stuff. So the first thing you might want to try to tackle when writing a bash script is say, well, are there generalities here? So if you look at all of the other kind of lectures between different days, they all have the same kind of format. The URL is almost exactly the same, except what differs is the lecture number. And so let's see if we can try to make this a little bit more generic. What if I try to kind of save the fact that we're talking about lecture 9 right now in a variable? So maybe I'll make a variable called 9. And then throughout the code, instead of referring to the number 9 explicitly, I'll just use my variable. So notice that this is a really long wrapped line. So there's just one line right here. Instead of using the number 9 here, I'm going to refer to my lecture variable. And then here, I'm also going to refer to my lecture variable. Now, one thing I'm going to just show, just because it's kind of useful pattern to see, is usually you can be kind of flexible when you include something in quotes or not. I don't want to. So you could put quotes around something. You don't always need to. It's kind of difficult to describe the rule for when you do or don't need quotes. Generally, I just think about is it unambiguous for bash to figure out what you're saying. And so when like it's in between those like slashes, it's able to figure out that lecture is its own variable. But sometimes if you're like putting it in the middle of a bunch of other words, you might need to put quotes around it to say, hey, this thing right here is the variable. But either is fine. And then instead of just unzipping this whole thing, I'm going to unzip this particular lecture. Now, if I wanted to, I could hopefully go change this to something like 8. And then when I run this, it should hopefully go download all of the files for lecture 8, which it just did, and it unzipped them. So that's awesome. And if you even want to, like you could see that, since I downloaded that zip file and then unzipped it, I still have that old zip around. So if I want to, I can even go ahead and just go delete that zip because I don't really need it anymore. I can go delete it. Now, excuse me. Now, if I try to run this again, I might run into some weirdness because it's already these files already exist. So that's what we're going to handle in kind of the next version of this. So I'm going to go ahead and cancel this. I'm going to go ahead and remove all of the lecture files here. And the first thing I want us to do is, it's kind of nice that I was able to put these in variables and stuff like that, but it would be nice if I could just, call that from the command line. Say like, download lecture 8, download lecture 7. So what I want to do is, instead of hard coding the number 8, I want to hard code the first variable or the first argument passed in. So now someone could run this saying, hey, download lectures, and pass in something like 6. And it will go and download lecture 6. Now, so there we go. Very kind of starting with everything we've seen so far, series of commands and a variable. So this is kind of talking about the stuff we saw in the first video. So now what if I want to make it even more general? Like, what if I know I'm going to be downloading a lot of lectures? So what if I want to pass in a list of lecture numbers? So in that case, what I could do is, instead of just hard coding a single argument, I can use all of the arguments passed in. Remember, with all of the arguments, it's that special at symbol. Whoops, that's supposed to be a $sign. That at symbol right here. And so what I could do now is I could do a for loop and say, like, for each lecture in my array of arguments, do this. And I'm going to go ahead and indent all of this and then say done. And now I should be able to do something like go download all the lectures for 1, 2, and 3. And it could go run through and do all of those. So you could see, and I should probably just remove that first lecture. Here, it's just like generally adding more and more complexities here. We just added a for loop to just loop over all of the arguments. Now, we already saw kind of in that earlier run when I tried to run, like if I try to run this command again, I run into these problems where it says like, oh, I already have this file. What do you want to do here? You could, one way of handling this is like, well, no, I'll just want to hit yes a bunch of times, or no, or whatever you want. Or you could enhance your script to add for the, or to account for those cases. So for example, what if I say, well, if I already have the directory for lecture 1, let's not download it. So I can wrap all of this stuff in an if statement to say, if this lecture exists, so if there exists a file called lecture, so it'd be like, oh, sorry, I believe that they're called lecture 2, lecture 1. So if there's something that exists that's like lecture 1 or lecture 2, then go ahead and echo already exists. Well, maybe I can even spell this out. Lecture already exists. Otherwise, then I'll go do all of this stuff with if I. And now if I go run this, quit, it's printed out that those already exist. So sometimes it can be hard to just start off and just know what the answer should be right away, but you can slowly start building things up. Now, the last thing I want to show is just one other common pattern that you generally see is what should happen if someone calls this script passing in nothing. Right now, we just don't do anything. We loop over nothing. But usually it's nice to enforce that your arguments have a specific format or there's a specific number of them. And so a very common pattern is, the first thing you do is check your arguments. So say something like, if the number of arguments is equal to 0, then echo. A common pattern for how to write a usage message would be something like usage download lecture.sh. And then we saw that there was that common format, like you give it a variable name and then you use this ... to say that there's more than one. And then we can tell them that this command failed because they used it incorrectly by exiting with some code. And remember, the exact number used doesn't matter as long as it's non-zero to indicate a failure. And now when we have this, if you try running it, it then gives us this error message. Basically, every command that we've used in this class uses patterns like this. Now, they could be written in different programming languages like C or Python, but they could also be written in Bash. All of this stuff is like core to developing Linux tools. So this example will be kind of with all the other files, and hopefully that you could use that as an example to work with of something to build up when we're answering some of these homework problems for homework 9. Do remember, homework 9 is going to be all about this bash scripting, and bash scripting is weird. And so it's okay if you run into bugs or you find yourself always looking back to our examples or the slides. That's totally normal. This stuff is strange, but we want you to get practice with it because it is used very commonly, for better or for worse. So that's all I want to talk about for this kind of lecture content, the stuff that's useful for your next homework assignment. We're running a little bit long because I wanted to go through everything a little bit slowly and make sure we highlight those important gotchas. What I finally want to do at the end of this video is I want to kind of do a quick recap of what we've seen all quarter as kind of to get a global view of the course and talk a little bit about what might be next and why we kind of structured the course like this. So if you think back to what I've been showing you all quarter, I've been showing you this roadmap where these are all the things that we cover in 391. Now, we talked about things like in the first week of the course, we talked about how the basics of a command line, how you can write a command with flags and arguments. We then took that further and said, well, actually, one of the beautiful things about Linux is that how you can compose commands, how you can take the output of a command and make it save to a file, or use a file as the input for another command, or chain two commands together to make the output of one become the input of the next. We learned about piping and file input and output redirection. The next week, we took this even a step further and said, hey, a huge set of problems is usually searching for a bunch of files and trying to do some operation on them. And so we applied what we learned the previous week of file redirection and piping to talk about things like the find command and how you can pipe that into xargs to run one command over each file that got found by find. We then went further, kind of switching from kind of the basics of Linux and command line stuff. We switched to Git because Git is a tool that powers a lot of what we use in industry and research, saving versions of our programs and our code bases so we can always go back and see what happened previously. So in the first week, we introduced the fundamentals of Git, like the terminology and some of the basic commands so that you could work by yourself. And then the week after that, we introduced how do you work with others using something like GitLab or GitHub and interacting with this remote using things like branches and pull requests. Then from there, we talked about the beautiful tool of regular expressions and how this enables you to find, search, and replace things in very complex ways with very succinct commands. And these kind of being able to search for whatever matches a pattern that you're looking for is such an important tool that computer scientists need. We then kind of went from there, went back to the world of Linux and Bash specifically, talking about users and permissions and talking about how like the Linux operating system works a bit. And then this week, talking about Bash scripting. So that is kind of what we learned in this course at a glance. We learned a lot about Linux. We learned a lot about specific command line tools. Now, I told you at the beginning of this course that this course is focused on teaching you fundamentals of Linux systems and common command line tools. And I think that we learned a lot this quarter, but I don't think that we've mastered this stuff yet. And I told you at the beginning that our goal is not to master this stuff. To master something, you have to continue practice. And this stuff is so powerful and useful, it requires a lot of practice to master these. I don't think I've fully mastered every single tool that we've used today, but I've mastered a lot of things and can use those as examples when I'm trying to learn something new. And so I told you on the syllabus that we are going to cover a lot of things. I just covered a lot of slides, and that was just one slide from each of the lectures that we talked about. I left out a lot of things that we covered that didn't like summarize the lecture. We learned a lot of things, but we are not focused on mastery. Mastery requires time and repeated practice, and that's just outside of what we could do in a single quarter in a class like this. But our goal here was to give you a survey of tools and ideas that kind of underlie anything you might do going from here. And so the first question I usually get about this course is, okay, am I actually going to use this stuff every day? you going to use every tool and every concept that we learned in this course every single day? Probably not. Almost surely not. Part of this is because these tools are used to solve problems, and that problem may or may not show up in your life every day. But if it does, you'll hopefully have a tool to tackle it. The other reason is that every single person has their own unique use case and needs, right? These tools are meant to solve problems. Different people have different problems they're trying to solve. And so naturally, you might expect that they use slightly different tool sets. But here in 391, what we're trying to teach you is a foundation. We tried to teach you a broad set of common tools that you're going to use 80 or 90% of the time to do simple tasks or as building blocks for complex tasks. We focused on giving you breadth and to cover these basics to enable you to learn whatever you want from now. This is exactly why in a lot of our homework assignments, we made them self-discovery, where we gave you a terminology or vocabulary to talk about something, and we're encouraging you to go look something up, because that's how you learn things. You learn things by relating a new idea to something you already know. And we were here trying to give you some building blocks, some reference points that you can then go out and learn whatever you want. And so to kind of emphasize this point of that you're not going to use every command we taught you, but hopefully we give you some building blocks. I actually went last week and I asked a bunch of friends, hey, I have this random bash command I want you to run on your computer. Can you please run this? Trust me, it's not going to do anything bad. And I explained to them what each part was doing. And what it did is it uses this command called history. History just shows you a long list of all the commands you've typed. And so I asked them, okay, well, please go run this command on your computer, and it's going to print out the top 10 most frequently used commands that they use in their jobs on a day-to-day basis. So I asked them, please send me that list. Please, obviously, like if there's any like confidential information, don't share that. It's only showing the command name. It's not showing any arguments or passwords you type in. And so they sent me this list. And this is it. You can find the command that I sent them in the notes on this Google slide. It's long and complicated, and we didn't talk about all the features there. But this is the list they sent me. I asked 6 people, if you count myself, I'm the 6th person. And I asked them from wide ranges of industry and academic experience. So I'm from the academic background. Most of the other people are from industry backgrounds of companies of different sizes, ranging from large companies to startups, and also people that work on personal projects. And so this command spits out their top 10 most frequently used commands, and the count and the command name. And what I did is I gathered all their commands that they use on an almost day-to-day basis. And I said, well, what are the ones I've taught you in 391? And I highlighted those in green. And you can see that of all 6 people, about half or more than half of the commands that they use on a day-to-day basis are the ones that we taught you in this course. And because these things are foundational and broadly applicable. Now, obviously, there are some tools that we did not teach you. There are lots of things out there that we could not teach in a 10-week quarter. But one thing I want to highlight is that these tools in black, the one that we did not cover yet, are ones that are very specialized to the role that person is in. So for example, with me, I use this tool called Tmuxinator a lot, which has to do with this tmux command. That's because I teach multiple classes, and it's really useful for me to switch contexts a lot. And so that's a tool that helps me in my work quite frequently, but does not necessarily help other people. One of my friends works at a very large company working on computer vision. So she does a lot of stuff with Python. And you can see all of the commands that I haven't taught you yet that she uses on a day-to-day basis. They're almost all focused on the Python programming language because the computer vision stuff she does is in Python. You can see the next friend on the right, he works at a medium-sized company on a bunch of databases work. The only commands that he uses that I haven't shown you are things about specifically talking to Google Cloud and using this database called MySQL. One friend does a bunch of stuff with personal projects. I linked to one really cool personal project he does. He uses most of the commands that we use on a day-to-day basis. He uses some slightly more advanced ones that we didn't have time to talk about called make, which you probably have experience with from 351, how to build a full project. And he also uses this thing called ag, which is just a fancier version of grep. But same idea, foundation, you can relate this idea of ag to something you already know, grep. And you can then go look up the documentation for ag or how to install it if you want to use that tool instead. And then the last two I saved because one big area of work in particularly industry, but can happen in research and other applications as well, is a lot of stuff working with the web. And this is the one that generally has the most gray or black commands, because there's a lot of commands to use in the web development world of NPM and NVM and all those things, but they're just commands. They use all of the things we talked about this quarter as well, like Git and moving around directories and removing files and editing files in Vim, or none of them are using Emacs because I probably kind of convinced them to use Vim, but there's nothing wrong with the Emacs. They are using tools that we taught as a foundation in broad and applicable ways. And the differences between them are the differences we'd expect because they all work in different jobs. So this is hopefully kind of a nice recap in saying that, yes, we learned a lot of useful things, and they probably will be useful in school or work or research or anything you do from here. What you get to decide is what problems you want to solve and identify if do the tools that we know so far solve them? If not, can you find new tools and relate them to tools we already know? And if not, can you go build your own tool? And I think that's the power of 391. It's giving you this flexibility to do whatever you want in the future. Not necessarily the specific remembering the exact syntax for if statements in bash scripting. It's more about enabling you to go do these things in the future rather than that specific example of what we just did. So thank you all so much for a fantastic quarter. It was nice getting to see you all during the class sessions. I know we tried to do our best in kind of an online quarter. I always love to hear back from you all, if you learned something cool out in the real world or in school. And I'll be sending information about how to fill out the course evaluation because we do look through that and that is very useful. So thanks again, everyone. And I hope you all have a great end of the quarter.